Hello, welcome back and thank you for joining as we go through the solution for question 8 of the May-June 2023 CSEC Mathematics Paper 2. It's our section 2 and we're dealing with algebra, relations, functions and graphs. Here we have a table of values, we have our domain from -3 to 4 and we're asked to work out some values that fit in our range or the codomain, and so we're going to just substitute these numbers into the function and get our values. Note that it says negative x squared or minus x squared plus x plus 7, and so we're going to substitute each value. Minus -3 squared plus -3 plus 7, and there's no reason why you can't do this on a calculator. If you're doing that, just make sure that you type in the signs as you see them and use a bracket for your numbers. So here we have minus 9, -3 squared is positive 9, but this minus makes it a -9, plus -3 plus 7, and this gives us -12 plus 7, and so we get a -5 here. So we're going to write -5 on our table. That one is worked out. For -1, same idea, minus -1 squared plus -1 plus 7, that gives us -1, minus 1 more here, plus 7, or plus -1, it turns out to be the same thing. So we have -2 plus 7, that gives us a positive 5. Here at 1, we have minus 1 squared plus 1 plus 7, and that is going to give us -1 plus 1 plus 7, which is 7. And of course the last one, -3, that's a plus there, -3 squared plus 3 plus 7. Here we have a -9, 3 squared is 9, but the minus here turns it back into a negative. Plus 3 plus 7, 7 plus 3 here is 10, and so it's 10 minus 9, which gives us a positive 1. And that closes out our table of values. So like I said, there's no reason you can't use a calculator to work these out. You shouldn't get these wrong in any case. These are marks that you can't afford to lose. So if you're using your calculator, make sure that you put your minus sign, open brackets, put the square, plus use another bracket there, and plus 7, and just type in the numbers and make sure that you get them and score the marks that are on this section. All right, let's move on to the next part. It's asking us to draw a graph. I've already copied the values that we need to draw the graph here, so it tells us the graph for the domain. The graph paper is already set up in terms of our scale. We're using 2 centimeters to 1 here and 1 centimeter to 1 on the y-axis. So let's begin. -3 to -5 is this point here, right there in the corner. Then -2 to +1 is right here, and -1 to 5 is here. Then we have 0 to 7, which is here, and 1 to 7, which is already here. That point was already marked, as in I previously marked it. 2 to 5 is there. 3 to 1 is here, and the last point is 4 to -5, which is here. And so what we need to do now is to make a smooth curve through our points to get our graph. So I'm going to try to use a red line so it can be easily seen. The idea with drawing these curves is that you start with one point and just keep looking at the next one. Let's see how well I do on this digital device. So it's easier doing it on the graph paper, but I'm just going to follow my own advice. Start with one point, keep looking at the next point, and you go through each point. Now notice that the thing stops there, it's kind of flat, but there's no point in a curve that is flat, and so you go through that point, and we're looking at the next one. My line is wiggling a bit, I can see it. Alright, I missed that one. But coming down, there we go. I'm just gonna go back and tidy up here. Alright, so that's my graph. Let me just go ahead and tidy this up. Of course, on your graph paper, you go through and you make sure that you draw a very neat curve and do not shade your line, so that you get it as accurate as possible. So this is representative of our function. I'm sure when you draw yours, it will be neater because you will be using cleaner lines. And all right, here we go. So this is our graph. What do we need to do with it? The questions are on the other page, so let's look on the other page and see what the questions are. First question is write down the coordinates of the maximum point on the graph. So the maximum point on the graph is the point at which the graph turns. The coordinate of the maximum point on the graph, write down the coordinates of it. Now you will notice here that the graph flats out here, but in reality it should go above. So the maximum point on the graph is the point at which the graph turns, and using this line here, you can see that the maximum point occurs right here when x is 0.5. Right at this point, when x is 0.5 here, that's when the maximum happens right here. But this is a number that we need to estimate. So look here, you notice that we're using 5 tiny boxes there. Each one is 0.2 from the calibration there. So I'm seeing 7, 7.2, 7.3. We could actually work it out algebraically, but so let's use the graph to do it. So this looks like 7.3. It's more likely 7.25. But I'm just going to write 7.3 there, just because. So the x coordinate is a half right here. That's the line of symmetry. 0.5 and 7.3 from what I'm seeing on the graph right now. Algebraically, if you work it out, then you might get something else, but we're using the graph. Write down the equation of the axis of symmetry. But we just got that. And notice it says equation, so we have to write x is equal to 0.5. That's a line which passes through the center of the graph, the middle of the graph right there. X is equal to 0.5, our axis. The next question says, use your graph to find the solutions of the equation negative x squared plus 7 plus x is 0. So this is a quadratic equation, and if you were supposed to use the formula or factorize or whatever method, then the solutions that you'll get using that method are the same that you'll get if you look at the points where the graph cuts the x-axis. So from this, what I'm seeing is, remember, going across each of these tiny boxes is 0.1. So I'm seeing negative 2.1, negative 2.2. That's one of the solutions there. So let me just write it in. X is equal to negative 2.2 in that direction. Negative 2, negative 2.1, negative 2.2. Going in this direction, we're going to be 3.1. 3.1 there. So I'm having 3.1 here. It's important that when you draw your graph that you actually use the values on your graph. For example, I'm familiar with some of these things. That's how the person marking the exam wants to know that you know how to find the answers. So even if you draw a graph that isn't entirely accurate, you want to make sure that you use the intercepts. And the examiner seeing that you know what you're doing is more likely to give you the marks. So make sure that you use the information. The intercepts are where your answer is. So don't be cheeky, and if you see somebody with a neater graph than yours and you look across and say, okay, maybe I should write down the answer that that person has. If it doesn't correspond to what you have on your graph, you may not even get that answer, even though you think you're copying a correct answer. So pay attention to that. Shouldn't be copying in the exam anyway. On the grid, that's in the grid over there, draw a line through the points -3, -1, and 0, 8. Let's mark that. -3, -1, -3, -1, so this point, and 0, 8, 0, 8. So we have marked those 2 points. Let's go back, sorry. -3, -1, and 0, 8. We have marked them. It says draw a line through them, and by line we mean a straight line. So I'm going to put a straight line through these 2 points. There's our straight line through those 2 points. And having done that, we realize that this line is touching the curve right here. I'm not sure if they're going to ask for anything to do with it, but just to show that it's actually touching it right there. Determine the equation of this line in the form y equal mx plus c. All right, so how do we determine the equation of the line that we just drew? Well, first we need 2 things. We need the y-intercept, which is c, and we need the gradient, which is m. So let's look at both. It cuts at 8, so this is our c. That's our c value right here. This value is our c. So we can start writing the equation by saying y is equal to something plus 8. Now what is that something x that we need? We can draw a triangle on our line, and usually it's nice to find a good spot to draw a triangle so you don't have to estimate. Now here's a good spot. Notice that this line passes right through there, so we can draw the line right all the way over here and drop it, and we have a nice right angle triangle where we don't have to do too much estimation. So using this triangle here, I'm going to label it so you can see it. We're going to label it as A, B, or call it C, call this B. From that, we're going to use the rise over run method. Rise over run to calculate the gradient. It's usually easier when you have the graph. The rise starts from here, starts from 2 to 7, so it's 2 to 8 rather. So it's 8 take away 2. It starts from 2, goes up to 8, and the run starts from here and stops here at 0. So it's going to be 0 minus this number here, which is -2. So that's our run. You could also count the boxes. So this is 2, and the rise is 1, 2, 3, 4, 5, 6. So notice that we get 6 over 2, and that gives us 3. So the line has a gradient of 3, and so we can simply just go ahead and put that in our question. Y is equal to 3x plus 8. Y equals 3x plus 8, and that is the value of our gradient and the value of our intercept, which gives us together the equation of our line. That brings us to the end of the question. Thank you for watching. Remember, you can find more past and practice papers on the website at csecmathtutor.com. If you found this video useful, please remember to share it with someone who is studying this material and needs to get some more insight and clarity. We thank you. Until next time, continue working hard.